Hello there, Dave Kabilka here with a short video on how to plot right ascension and declination on our retrograde motion lab. So the part I'm going to explain to you has to do with where it says graphing a retrograde loop. And the question I'm going to answer is, what do we do with these coordinates here? These are coordinates analogous that are analogous to um, latitude and longitude on Earth. In fact, they are an extension of latitude and longitude on Earth. If you take that system and extend it out into space until it comes in contact with that hypothetical celestial sphere that we read about in the early chapters of the textbook, we get this system of what we call right ascension and declination. Right ascension is essentially longitude. Declination is an extension of the latitude system. But the numbers have different names, whereas with latitude and longitude we have degrees and minutes and seconds. With right ascension we have hours and minutes. With declination, we have degrees and minutes, so it sounds similar there, but it's important to bear in mind that the hours and the minutes aren't talking about time. They're talking about angular distance across the surface of a sphere, in this case a hypothetical sphere. But let's just go through the routine of plotting some of these points. So what I'm going to do is just walk you through plotting the first set of points on this lab, and that is the one for the position of Mars for 11 October, right here, October 11th. So you've got, looks like 20 or so points to plot. We'll get you started with this very first one, and I think once we get that done, you'll see how this whole system works. And what I'm having you plotted on is not the whole picture of the celestial sphere. It's just one little patch of the celestial sphere, and it's shown as just a simple rectangular map. So let's do this. Let's take the first point, which is a right ascension of 8 hours and 5 minutes and a declination of 21 degrees and 49 minutes. So here's the right ascension scale across the bottom. Here's the declination scale on the side, and the numbers are hours in right ascension. So let's plot the hours point first. Let's figure that out. So it's 8 hours and 5 minutes. So here's 7 hours, here's 8 hours, here's 9 hours. So it's going to be somewhere between 8 hours and 9 hours. The question is, what do these intermediate tick marks mean? Well, there are 60 minutes to every hour in right ascension, just like there's 60 minutes to an hour in time. So each tick mark is some fraction of that total of 60 minutes. Well, usually it's broken up into some even multiple of the total 60 minutes. So there's one tick mark, there's 1 mark, 2 mark, 3 mark, 4 mark, 5 mark, and then the 9 would be the 6th mark after the 8. So 60 minutes divided by 6 is 10 minutes per mark. So this point here is 8 hours 0 minutes. This is 8 hours 10 minutes, 8 hours 20, 8 hours 30, which is halfway to 9 hours, 8 hours 40, 50, and 60. So 8 hours and 5 minutes would be right about here. I tell you what I'm going to do. I'm going to insert a line there, an arrow, so we can kind of see how that goes. So I'm saying 8 hours and 5 minutes is right there. I'm going to run that all the way up across the whole graph, and that might be hard to see, so let me format that line. I'm going to make the line a lot thicker and make it a really bright color. There. Okay, so that is 8 hours and 5 minutes. Now let's plot the position plot the point of 21 degrees and 49 minutes. So here's 20 degrees, here's 21 degrees, here's 22 degrees, and same deal, 21 degrees 0 minutes, 21:10, 2120, 2130, 2140, and 2150. So 50 is pretty close to 49, and it'd be really hard to make a distinction. In fact, I think the lab instructions tell you to round to the nearest 5 minutes, which is probably good enough. So let's insert a line. Insert a shape at 21 degrees. What do we say? 50 minutes, 49. I'll go a little bit under the 50 so we can see it, and then we'll take that out to where it crosses. I'll format the shape so we got a better color to work with. Make it thicker, give it a better color. We'll make that kind of a green so it shows up better. And there you have it. Where those two lines cross, that's the position of the first point for October 11th. That's where Mars was in the sky on October 11th of that year. So I'd want to put a data point, and you can certainly do this on the computer. And when you hand in your lab, you could hand it in as a thing plotted on the computer. So I'm just going to insert a shape, some crazy shape. I don't know if this is going to work. And I'll just adjust it a little so it's sitting right on top of that cross. And there it is. Now if I delete these lines to clean it up, just highlight it and delete it and delete that line. My plotted point stays in place, and there I have the point plotted for October 11th. There you have it. Now you can see how we plot right ascension and declination on the graph from the data that's provided on the lab for the retrograde motion of Mars. Okay, this is Dave Kabelka. I'm signing off, and I will see you on the computer. Thanks for watching. Bye-bye.